have a conference in Kuala Lumpur. So those of you who has those of you who has research that involve Rasch model are very welcome to present, and then sharing and then learn each other from the conference, right? So Prof Yanji is ex real expert in Rasch model. So I saw you this book. So he's one of the co-author of this what we call is a standard textbook in Rasch model, writing with Professor Bond. Okay, and it is the highly cited textbook in Rasch model, more than 8,000 citation. So we are very happy to have here and then share to us about Rasch model in educational research. Okay, okay, Prof Yanji, the screen is yours.
Okay, thank you, Professor Bambang. Professor Bambang and I have known for many years since the first time we met in Prom's conference. I really appreciate Professor Bambang's great effort in promoting the Rasch measurement in the Southeast Asia, especially in Malaysia and now in Indonesia. So when he invited me to give a workshop to the students in Indonesia and the colleagues in Indonesia, I immediately said yes, because I think Professor Bambam and many old friends. Oh, I see some old friend here. Zali, hi, how are you?
Oh, fine, thank you, Prof. Yanzi.
Yeah, we have a very group, a core group of dedicated person who are so keen on promote the benefits of the Rasch measurement in solving the measurement problem in social science, including the education fields. So we want the advantages of the Rasch measurement to be recognized and used by a wider range of audience, so we can make our measurement in social science better. Okay, let me share my screen first. Can you see my screen? Okay, good. So the topic I will discuss with you today is the Rasch measurement in education. A little bit, although Professor Bamba has given me a quite warm introduction, I just want to add a little bit more information about the my personal research and teaching experience interest. I have two different but closely related research interests, which is one is applied measurement, okay, in particular the Rasch measurement. Another one is educational assessment, in particular the assessment research in classroom. So in the past several years, my major interests are how to make these two areas can benefit mutually. So for example, how we can use the Rasch measurement to enhance the design and implementation of assessment in classroom. So I believe all of you, the audience today, you have your own particular research area, okay? But I believe the Rasch measurement will provide us with a very solid and useful tool which can be applied in your own particular research interest to enhance the quality of your research and the implication of your research. I've done many professional development workshops in Hong Kong, Macau, mainland or other countries. The overarching aim for those professional development are also two-folded. One is to promote the use of Rasch measurement. Another one is how to enhance the best practice of classroom assessment in different education contexts. A little bit background about my university, because I think probably not all of you are familiar with the education University of Hong Kong. Our university is a teacher education institution. So obviously, our research strength is on education. We have done quite good in the QS University ranking. In the most updated version, the EDUHK ranks top 4 in Asia and 21st in the world. So we are doing good. The department I'm working for currently is the Department of Curriculum and Instruction. So you can judge from the title of the department. We are focusing on research about the curriculum, pedagogy, assessment, and as well as the online or digital learning. We have quite good research profile. For example, in the most updated Stanford list of the top 2% of most cited scientists in the world, we have 5 colleagues in that list. Remember, we only have roughly 20 colleagues, so almost 1/4 of the colleagues are in the top 2% most studied scientists. So, and nowadays we are quite keen on expanding our research collaboration networking to other countries. So if any colleagues so in Indonesia, you have some interest in doing the research on curriculum, pedagogy, assessment, or digital learning, you're welcome to approach us for the possible research collaboration. Okay, for today's talk, I think I will focus mainly on 2 elements. First of all, I will introduce the basic idea about the Rasch measurement. Second, I will introduce some commonly used methods or areas that we can use Raschman to enhance the measurement scenarios. Okay. I want to do a little bit survey here before I start introducing the Rasch measurement. How many of you have not heard about Rasch measurement before? Could you please raise your hand? You can just click the button. Never heard about it. So it seems that just one. So most of you should have some basic understanding about Rasch measurement, right? That's great. That's great. I think this largely probably be attributed to Professor Bambang or Dr. Zali's contribution in this area, because when for example, I go to the mainland China or the Japan or South Korea to introduce Rasch measurement, I usually do a similar survey, and I found not so high percentage of people who are familiar with Rasch measurement, and even some of them, some high percentage of them, never heard about Rasch measurement, which is a pity. Okay, so what is Rasch measurement? I will, even though you have some, all of you have some basic understanding about this concept, but I would like to challenge you in a more in-depth understanding level. Let me ask you a very fundamental question about the Rasch measurement, the measurement. Okay, we know that there are generally 2 types of science. One is physical science, another one is social science. Okay, in both areas, people are doing measurement. For example, in the physical science, we measure the kids, the height, the weights, right? In the social science, we measure the students' learning motivation, the mathematical achievement level. So all these things, all these behavior, all these activities, we call it measurement. But what's the fundamental difference between the measurement in physical science and social science? I would like to give you 3 minutes, okay, 3 minutes to think about this question. If you have a peer sitting around you, then you can have some discussion. If no, then do some self-reflection. What's the fundamental, remember, fundamental difference between the measurement in physical science and social science? Okay, 3 minutes, please.
Okay, guys, you can also write in the chat room if you don't want to speak directly.
Yes. We see there are some comments in the chat box. Rasch says that in physical science we have measurement devices, but in social science we do not have. That's an interesting point. I think it depends on how you define the measurement devices. For example, if you devise the questionnaire or a test paper is a measurement devices, then we have. Of course, we do not have a measurement device in social science like a ruler, right? So that probably is the problem we have. Elena says that in physical science, measurement can be seen physically, but in social science, it is latent. Okay, that's a very good point. For example, when you measure a kid's height, we can use a ruler, right? We can read the figures, so it seems very traceable, observable. But in social science, for example, if you want to measure students' learning motivation, we usually use a questionnaire. But what's the units? What's the object we are measuring? Is since it's latent traits. In physical sciences can be measured physically. Social science something latent. Okay, similar points. Who is the guest? The measurement is done based on equal distance between units. I think this is a very, very important point.
Hello?
Equal distance between units. Physical measurements provide more certainty, precision, accuracy, while human measurements are weak. I totally agree with you. But I think this is the consequences. That is because we lack something in social science. So the consequence is that we do not have a measurement which are so precise or accurate as the measurement in physical sciences. So this is the consequences. Okay. In physical measurement, they have units of measurement, exact ratio. I think in social science, we also have units of measurement. The difference is the units we are using in physical science and social science is different. Okay. In social science, we are studying and measuring intangible things. So it's easily to be subjective, right? Which I agree. Also because of the human bias, okay, it's easily to be introduced in the social science measurement. Social science equals to latent traits, physical science equals to precision and accuracy. Okay. Okay, so I would like to, if I may, I would like to invite the guest. Who is guest? Okay, if you don't mind, can you share a little bit more about your thinking about the equal distance between units? Z. Yeah, I see the name, Z. Do you mind to share you thinking about the equal distance between units?
Yes, Professor. Because in physical science, let's take ruler as a ruler as an example. So the distance between 1 cm and 2 cm, and also maybe 5 to 6 is the same. But in social science, we rarely have that kind of concept. Yeah.
Yes, exactly. And okay, we have some new message. Let's have a look. Yeah, social science need more approaches. Okay. Okay, I think this is very fruitful discussion, and it seems that basically all of us agree that there are quite difference between the measurement in social science and physical science. And as Z just mentioned, a very core or fundamental difference is that the physical science, they have some units, and that units are measured in some equal distance, just like 1 cm, 2 cm, or 5 cm and 6 cm. The difference between these units are the same. That is 1 cm, right? No matter this is in Hong Kong or Indonesia, the 1 cm is a standardized units. And it could be interpreted and researched or measured in the same way, in the same units. So, and these units with equal distance very crucial for fundamental measurements. The reason is, if we have the standardized units with consistent size, that means when we do the measurement, our job is very simple. We just need to add those units one by one. Okay, so the measurement becomes a repetition of units amount. For example, you measure kids' height, the kids probably 120 cm high, right? So the measurement's job is use a ruler to let us know the kid's height is 120 repetition of 1 cm. And 1 cm will remain invariant no matter how tall the kid is, no matter how where the kids are measured, no matter what ruler you're using, right? So if we have these standardized units, another very important feature of a fundamental objective measurement is no matter which instrument you are using, and no matter who or what relevant person or things is being measured, we are in the same measurement framework. We are in the same measurement framework. But think about the measurement in social science or in education. When you want to know a student's mathematics academic performance, what we do, we design a test paper about mathematics, right? Then we ask the student to answer the question in the test paper. We mark them performance, and then we do some interpretation. And then the student will have scores. For example, if the full mark are 100, some student will have 90 marks, some student will have 70 marks. Then we will have interpretation. The student who got 90 marks have a higher level of mathematics performance than the student who got 70 marks. But that's all. You do not know exactly what the student's mathematics performance. For example, what exact level of the students who have 90 marks in this test paper? It's very difficult to describe the students' real or actual mathematics performance because we do not have standardized units about students' mathematics performance. That's the problem for the measuring social science or education. So our targets, I think for many social scientists or educator, our targets is trying to achieve the objective measurement which have been achieved in the physical sciences. So if we want to achieve this goal, first of all, we need to understand the necessary feature of the objective measurement in the physical science. Then, based on our discussion and my elaboration just now, there are two very fundamental requirements for objective measurement. Number one, we need to have an interval scale. Interval scale means in that scale, the units are with equal distance. The second feature is the person measure should be independent of items, and item calibration should be independent of persons. So these two are the fundamental requirement for objective measurement. Let's have a little bit more discussion about these two requirements. The first one, interval scale. What is the interval scale? I think according to the classic work of Stevens, we usually agree that we have a 4 level of the scale or data. The first level is nominal. For example, gender, male or female, right? So this kind of data, you can still assign number to them. You can code female as 1, you can code male as 2, right? It's still number, but this number just a label, in this case. There's no meaning of order. You cannot say 1 is better than 2 or vice versa, 2 is better than 1. They are just labels. The second level is ordinal scale, okay? Ordinal scale have some meaning of ranking, have some meaning of order. For example, after tests, we will give a student ranking in a classroom from number 1 to number 30. These are numbers again, but these numbers is not only label because they reflect the order on the amount of the properties. We usually know that the top 1 students is better than top 2, then top 2 is better than top 3, etc. Right? So the 1, 2, 3 until 30 now has some additional meanings than the labels. So for this kind of data, we call it ordinal data. And then we move up to the interval scale. Interval scale compared to the ordinal scale, interval scale have an additional feature, which is equal distance. Okay. In other words, the distance between numbers have the same meaning. Okay. The difference between 1 and 2 are the same as difference between 2 and 3, and also the same between the different 29 and 30. Okay. For example, the temperature. This is a typical example of the interval scale. And then if we move up again, racial data. Racial data have another additional feature, which is an absolute zero. Okay, absolute zero. For example, weight, height, time. If you say this is a 0 in terms of weight, that means this object has no weight or this subject has no height. But think about interval scale. For example, temperature. When we say the temperature is 0, does that mean there is no temperature? No, 0 degree. Yes, Mohammed, please elaborate your idea since you want to. Okay.
We cannot make sure the 0 is low. Still, this was for this of the temperature.
Sorry, I cannot hear you. It's not so clear.
Means zero cannot totally fixed indicate the such zero temperatures. It can be more or it can be less than zero.
Yes, exactly. The 0 degree in terms of temperature does not mean there is no temperature, right? It's just arbitrary points we set on this scale that stands for one particular level of the temperature. So the other temperature could be higher or lower. It's not the absolute 0. But for the ratio data, the weight, the height, the time, there is an absolute 0 point. That means none. Okay, 0 properties. So we need to have a very clear understanding about this 4 level of data, especially between the ordinal, interval, and ratio, because I think a nominal scale is quite easy to be differentiated. But for the ordinal, interval, ratio, sometimes it's quite confusing. It's quite confusing. In the social science and education, I think our target should aim at the interval scale rather than the ratio, because by nature, most of the latent traits we are measuring in the education, we cannot identify absolute 0 points. Okay, so I think the practical goal for our social scientist or educator is that we need to identify, or we need to construct interval scale for education or for any area you are interested in. Here's a little bit exercise, okay? There are several types of data. Could you please tell me which level of the scale that this data belongs to? For example, tail number. Is this nominal, ordinal, or ratio? You can speak up. Nominal. Okay, very good. This is nominal. Temperature, we have discussed. This is a interval. Rank is
Ordinal.
A present weight is
Ratio.
ratio. Research methods,
Nominal scale.
nominal, yes, because it's just label. We cannot say quantitative better than qualitative or vice versa, right? Schooling banding. I'm not sure whether there's schooling banding in Indonesia. In Hong Kong, we have school banding.
Ordinal.
Yes, ordinal. In Hong Kong, school banding 1 is better than banding 2, and better than banding 3. So, but we do not know whether the distance between banding 1 and 2 are equal to banding 2 and 3 or not, right? It's just ordinal. It's just order, ranking, rather than the meaningful distance. Okay, why is that? Why there are so fundamental difference between the physical science and the social science in terms of the measurement? I guess this is largely attributed to the object we are measuring in social science or education, because what we are interested in this area are something in the head. Okay, we cannot touch it. It's intangible. So it's very difficult for us to directly to observe or measure those traits we are interested in. What we can do up to now is that we use some indirect measures or indirect devices. We use questionnaire, we use self-reports, we use observational checklist or test paper. And based on students' behavior on these indirect devices, we make some interpretations. So I think this is the nature of the social science measurement, and which I guess in the foreseeable future, it's very difficult for us to change this scenario. So what we need to do as a measurement perspective is that how can we deal with this data connected by these devices, by these indirect devices. Okay, let's have a closer look at the data we have connected by this kind of indirect devices. For example, this is a data connected from a test paper. There are 5 students, okay, have a score on this test, 45, 52, 59, 91, 98. And in particular, we found that the difference between 52, 59 are 7 marks, right? And the difference between 91, 98 are 7 marks. So I think my question is that this difference between these 2 gaps are the same, because numerically they are 7, both are 7, both gaps are 7. But do you think this distance are the same, or we can say this is the interval scale?
No, it's not the same.
Yeah, why?
It's not
We
the
need
same.
to see also the effect of difficulty level of the questions that makes the students get the scores like that. We do not know 52 to 59 is coming from which questions, 91 to 98 to which questions. So if we are considering about difficulty level of the question, so +7 differences are not going to be considered as the same.
Okay, very good, very good. So I think at least we do not have proof that to tell us these 2 gaps are the same, right? Or even sometimes we do not even need to have some measurement expertise. As a teacher, you can evaluate this scenario by common sense. You will find it's highly likely not the same. Why is that? If you want to help the student to improve from 91 to 98, it could be quite difficult, right? It's quite difficult because of the ceiling effects. The student needs to be improved from 91 to 98 is very difficult. However, a student, the performance improved from 52 to 59 marks, it could be quite easy, right? Because it's in the relative lower band of the latent traits in terms of if this is a math test or English test. So by common sense, we can also feel that these gaps or this distance could be highly likely, could be uneven, right? And let's put this in another more obvious example. And we can see the second feature of the objective measurement is not met in our conventional education tests. Say we have a test, okay, and then there are tests which is have 5 items. The triangles represent 2 items. Then we have 2 persons. In the first scenario, one person scored 5, another person scored 0, because all the items are harder than the left-hand person's ability, but easier than the right-hand person's ability. So they have a 0 or 5. And then our interpretation for this scenario will be one person is much, much more able than another person, right? Because one is 0, another one is full mark. But look at the second scenario. In this scenario, all the items are very, very easy items. So both persons, they get 5, that is full marks. In this scenario, our interpretation is that these 2 persons at the same level, and etc. You can look at the third and the fourth scenario. The core message delivered by this comparison is that our interpretation about the 2 persons' ability depends on what items we are using to measure them. You use very difficult item versus you use a very easy item versus you use a combination of easy and difficult items, you will have a totally different testing results, as well as a totally different interpretation about the student's ability. So we cannot call this kind of measurement is objective because they are variant according to the items. And this is not what we want. We want real measurement. We want objective measurement that no matter items we are using, we can precisely, of course, within the error, we can reasonably precisely to predict the student's ability on the latent trait scale. Okay. However, the conventional testing methods cannot meet these requirements. So I think up to now, we can largely arrive at the agreement that the conventional measurement in social science or education is not objective, right? So what can we do? What can we do? We can refer to Rasch model. Okay, I need to make a personal note that I do not think Rasch model can help us 100% to arrive the objective measurement in social science. I don't think so personally. Some people think. But I think Rasch model is a way, probably the only way available up to now to help us to getting close to the objective measurements, even though not 100%. Okay, so by this nature, I think we still have the urgency to learn what is Rasch model and how to use it in our own particular research area. So Rasch model principle underlying the Rasch model is very simple. That is, a person's response to an item is determined by difference between the person ability and the item difficulty measured on the same continuous scale. Okay, so in Rasch measurement, the calculation is always about pairwise comparison between the person ability and the item difficulty. Okay, and all based on raw data. So the technically speaking, the Rasch calculation quite simple, and the principle is quite beautiful. I would say it's quite beautiful and simple. That is, when they do the pairwise comparison between the person difficulty and the item difficulty, person ability and the item difficulty, they are saying that if the ability equals to the difficulty, then the person succeed on that item, we have a 50% probability. Okay, by common sense, I think this is easily to understand, right? You just think about two boxers, they are doing boxing. If their ability and difficulty, they are at the same level, then each of them to win the game, the probability is 50%. If the ability is higher than the item difficulty, then the probability for that person to get the item correct should be more than 50%, right? Or if the person ability lower than the item difficulty, then the probability for that person to get this item correct should be lower than 50%. We do not need formulas. We do not need formulas. This is all about common sense. I agree, right? And if the same person are trying different items with various level of difficulty, then the probability of that person get the item correct should be decreased when the item difficulty increase. Is this right? For the same person, if the item difficulty increase, just like in this figure, then the probability for that person to get the item correct should decrease, right? This is also, again, a common sense. And then this is a formula. To me, I think this is quite beautiful formula. Okay. This formula is just in the mathematical form to elaborate all the principle we just discussed. The probability for a person to get the correct answer on an item is determined by the difference between the person ability and the item difficulty. Okay. If we put this in the figure, then you can see if the person's ability equals to the item difficulty, okay, in the actual excess, then the probability of the person get that item correct should be 50%. If the person's ability increase or the item difficulty decrease, that means the difference between the ability and difficulty will increase. Then the probability of a correction will increase. Otherwise, the probability of a correct answer will decrease. So this is the very famous, and I think many of you are familiar with. This is ICC, item characteristics curve. Okay, this is one item. If we have many items, then we should put a similar shape into this figure. And finally, the Rasch measurement will help us to build a scale. Both the items and persons are calibrated on the same scale. And the more capable individual and the more difficult items will be placed on the top. The less capable individuals and less difficult items will be placed on the bottom. For those who are not so familiar with the difference between the classic item testing theory and the Rasch measurement, probably you'll think, oh, this is nothing big, okay? It's just a ruler and then two things put together. But if you're familiar with the Rasch measurement and you have some experiences in applying the Rasch measurement in your own research area, you will see this is a big step for measurement. Because if you can place the item and the person in the same scale and in a relatively standardized units, it's very convenient for you to make a prediction about person's performance on the particular items, and which have many important implications for us. For example, if you're a teacher, you can know how to teach your students based on this information provided by this figure. Okay, that's the first the thing we can see, the benefits we can see from the Rasch measurement. The second benefits we can see from the Rasch measurement is the interval scale. Because by the mathematical calculation, by putting all them into the same scale, we can transfer the raw data into the Rasch scale. The Rasch scale's units is logits. We call log-odds units, logits. And what's the beauty of the logits is that when the data fit the dichotomous Rasch model, a person with ability one logit higher than the item's difficulty always has a probability of 73% of success. So you can feel that by doing the Rasch calculation, we transfer the raw data, which is, as we just discussed, raw data are ordinal data, right? We can transform the ordinal raw data into the interval Rasch measure in logits. And why the logits are in interval data is because the one logits stands for some particular percentage of success probability. In this case, if one logit higher than the item difficulty, then the person will always have a probability of 73% of success rates. And also, based on the same calculation, you can determine when a person is 3 logits above the item, then the person have a 95% chance of success. When a person is 3 logits below the item, there is only 5% chance of success, etc. Okay, and this correlation between the logit difference and the chance of success will remain invariant across any context, any test paper, any survey. Okay, this is invariant. So now, I think the scenario Rasch measurement set for us, or for the measurement in social science, is that we need objective measurement. Okay. If we need objective measurement, we need to assume that relative ability of two persons should be constant irrespective of which item have been used for measuring the person. If this is the case, then Rasch model holds. Okay. If Rasch model does not hold, which means the objective is not, the measurement is not objective. In another word, Rasch measurement is a golden standard for measurement in social science. What we need to do is to verify our data against the Rasch model. If the model data fit is satisfactory, which means Rasch model holds on your data, then the data you connected can be some level of objective measurement. If not, that means model data fit is poor, which means Rasch model does not hold on your data. Then the data is problematic. Okay. This is we so-called the data fit the model approach rather than the model fit the data. And this is also, I want to warn you about the 2PL or 2P or 3P IRT model. I think some of you may be familiar with these IRT models. Basically, anybody who are familiar with Rasch model should be familiar with IRT models. Okay. But there are many arguments about the difference between Rasch model and the 2PL or 3P IRT model. We know that in 3P IRT model, the three parameters are difficulty, discrimination, and guessing. Okay, if we are fit the data into a 3P parameter IRT model, that means all these three parameters need to be determined by the data. If the 2P IRT model, we set the guessing as a constant, let the other two to be estimated. However, Rasch model, we only have one parameter to be estimated. That is the item difficulty. That is the item difficulty. So some people would say the Rasch model equals to one parameter IRT model. Okay, I'll stop for a moment here. What do you think? What do you think? Do you think Rasch model equals to one parameter IRT models or not? Any ideas? This is a very challenging question, okay? Do you think Rasch model equals to one parameter IRT models? How about we do a survey again? If you okay, we see some no, okay. Z again said we cannot say Rasch model equals to one parameter IRT model because Rasch model use the data fit the model approach, while IRT use the model fit the data. Very good, very good. I think this is a very core and a philosophical difference between these two models. Mathematically, you can say Rasch model and one parameter IRT model are the same because mathematically they're the same. The formula are the same, right? But I totally agree with Z that we have another answer. IRT has constant, Rasch does not have a constant in the formula. Okay, there are some minor differences. But the most important difference is Rasch model from the perspective of philosophy, measurement philosophy, we use the data fit the model. That is, data has to fit the model. If the data does not fit the model, data is rubbish. The model is still the golden standard. However, IRT model, no matter 1PL, 3PL, 1PL, they use a different philosophical approach. That is, the model fit the data. In their view, the data is the golden standard. The data is always the good thing. What they need to do is to manipulate the models, to add or remove parameters, to make the model fit the data. So you will observe that in mainly empirical studies, in some comparison studies, they will find, oh, the 2PL and 3PL IoT model have a much better fit than the Rasch model, which of course the case because you have more parameter to count for the variance in the data. So obviously you will have a much better fit. But you're wrong in the very beginning because what we want is objective measurement, right? Objective measurement, that means we need to have a golden standard. And then based on that golden standard, we need to connect the data and trying to make our data to be aligned with the golden standard. Just imagine if in the physical science, if you find there are some problematic or there are some misfits between the data and our rule of measurement, what do we do? What do we do? We will not challenge the correctness of the ruler or the definition of 1 cm or whatever have already been arrived by all the physicians around the world. We will challenge, what's wrong with your data? What's wrong with your data connection procedure? Because we believe there is a golden standard in the physical science in terms of measurement. If you do not align with those measurement standards, then data is problematic. But in social science, if you are using 2PL, 3PL IoT models, that means, oh, when you connect data, you find there are problematic between the in terms of the fit between the model and the data. You will change the model. You will change the standard to accommodate your own data, even though your own data probably just rubbish. Okay, so you can imagine by this approach, many data analysis results actually are useless or even worse, misleading, because they are using shaky measurement standard. They are using different parameters to accommodate the rubbish data, okay, in order to have beautiful fit, which is not the perspective of objective measurements. Okay, let's check this difference from a technical view, okay? ICC again. This is ICC, all of us are familiar with. If we are using Rasch model, then the different items ICC should behave like more or less the same this way, okay? The slope will be identical. Its only difference is the difficulty, its items difficulty, okay? So for this particular level of ability, item B is the, okay, you tell me, which one is the most difficult item? ABC, which one is the most difficult item?
Item B.
Item B is most difficult. Why? Why is that?
Because the ability logits is the less than item A and C.
Less than. Okay, there's another different answers in the chat box. Item C is the most difficult. So, if Lu, do you mind explain your answer? Why item C is most difficult?
Yeah, because the probability to answer the probability to reach the correct answer 1.5, they need the ability higher than item A and item B from the ability logits.
Yes, exactly. We can judge the relative difficulty of these three items from different way. As Blue just mentioned, if you use the same probability of correctness, that means you can see from this figure, item C will need much higher ability level to get this item correct than item A and B, right? And another way to judge is just look at the dot lines. The same ability person who got item B correct probability is, I think, nearly 90%, right? It's very high. And for the same person who got item A correct, probably just 20%, very low. And this person, the same person, got item C correct probabilities very close to zero, right? So, which means item C is much harder than A in turn much harder than B. Anyway, okay, this is just a little quiz. The main idea in this figure is that you will observe that for this A, B, C, for these three items, no matter how able the student is, no matter whether the student is very, very able student or very poor students, you will observe that the relative difficulty of these three items remains invariant, right? Do you know what I mean? You can compare for very less able, for very poor students, item C is still the most difficult item. Item B is the easiest item. For very, very able student, which is on the right-hand side, item C is still the most difficult item, and item B is still the easiest item. The relative difficulty level of these three items remains invariant. Do you think this is desirable results for objective measurement? That means we require the relative difficulty level remain invariant across different level of ability. Do you think this is right or wrong? This is right, because for objective measurement, for any level of the students, we always expect that they will have a lower probability to get the harder item correct, right? And they have a higher ability to get the easy item correct. So this is objective measurements requirement. But if you look at the 2PL or 3PL IRT, you will find they are not invariant. They are not invariant. For example, for a person whose ability is around minus 1.2 or so, and then you will find the black item is the easiest or hardest, the black one.
The hardest.
The hardest. The pink one is the easiest, right? But for more able students whose ability is 1.4, you will find the black item becomes the easiest item. And the pink became the second hard, and the blue becomes the hardest item. Which means in the 2PL, 3PL IRT model analysis, the item's relative difficulty will be changing according to different level of ability, students' ability, which is not objective measurement, Okay. So I think for the difference between Rasch measurement and IRT, there are many academic debates on this topic. Mathematically, they are quite similar for Rasch measurement and 1PL parameter, but there are more fundamental difference in terms of the philosophical point of view on the measurement between Rasch and multi-parameter IRT. Okay, Rasch measurement insists that the data should fit the model. Okay, only by doing that we can have the possibility to arrive at the objective measurement. Otherwise, we are always changing our standard to accommodate our rubbish data, which are obviously not objective measurement. Okay, so let's give a brief summary. A Rasch measurement transforms ordinal raw data to interval measures, which I think probably the most significant benefits of Rasch measurement. However, if you are only interested in one test, or your interest is just ranking students, then Rasch measurement does not tell you much more than the raw score, because all the Rasch logics measures are based on the raw score. They just do some transformation and trying to make the ordinal raw data into an interval scale. But if you're just interested in ranking, don't bother Rasch measurement. Just use the raw data, okay? Because the result will be the same. And you do not intend to generalize your results to other tests or other scenarios or other contexts. Don't bother Rasch measurement, because you can use raw data to do that sufficiently. Okay. But if you want to generalize your test results, you want to compare your results with other different scenarios, and you want to perform some statistical analysis on your data, then Rasch measurement is what you needed. And particularly the statistical analysis means a very conventional one. For example, t-test, ANOVA, regression, correlation. So our standing point is that when you want to do those conventional Rasch analysis, statistical analysis, you need to do the Rasch analysis first. Why? It's because all those conventional statistical analysis requires or assume your data is interval. Your data is interval. If your data is not interval, which we have testified in our previous discussion, you cannot do those statistical analysis. Okay, just a very simple example. For the ordinal data, say the students' ranking in a classroom, will it do an average? For example, in my class, where I have 30 students, I rank them from 1 to 30. Will it do the average of those ranking? You won't, right? Because it's meaningless. To average on ranking data is meaningless. However, every teacher will do average on the student's raw score on a test or on test paper. Am I right? Every teacher will do the average. However, we have proved that the test paper raw data are not interval. They are just ordinal. For example, a student get 90 marks are higher than student who got 80 marks, which in turn higher than the student who got 70 marks. But the difference between the 70 and 80 and 80 and 90 are not the same. So principally, we cannot conduct the conventional statistical analysis on raw data. We can only conduct the statistical analysis on Rasch calibrated interval data. That's a crucial point. Okay, I think I will stop here for, say, 3 minutes, because there are a lot of information, and if you have any questions, you can raise it, or if you have any comments, we can discuss a little bit further. Okay, 3 minutes, then we can start the second part.
Right. Thank you very much, Prof. Yanji. So we have a break around 3 minutes. So prepare your question, or if you want to talk directly, it's welcome. As well as if you want to write a question or comment in the chat room, right? So we'll take a break from 3 minutes.
Okay, no question right now. Then we move on.
There's one question in the chat room, Prof. Yanzi.
Yeah. I think this is a very important question. And this is also what I like to share in the second part. But I'm happy you raised this question at this moment. Okay. Yes, many people say the Rasch measurement is only useful for testing the instrument's validity or reliability or psychometric properties. And if you want to analyze the data, SPSS is enough. I think this is echo the last point of the first part. I just highlight the statistical analysis and Rasch measurement, the difference or the relationships. First of all, it is right. Rasch measurement is very useful for checking the psychometric property of instruments. So I would recommend all of you to use Raschman as a tool to test the psychometric properties of your instruments. That's first. But the second, if you want to do the analysis, SPSS is enough. I don't think so. Technically, or in reality, many people are doing that. So they connect the raw data from Richter type scale, put all this data into SPSS, run analysis, t-test, ANOVA, regression, SEM, etc. But we would say this is wrong. Okay, this is wrong. Why this is wrong? It's because, as I just mentioned, all those statistical analysis have one assumption, very important, but largely ignored by many people. That is, all the data you put into the conventional analysis, t-test, ANOVA, regression, whatever, the data need to be interval. The data need to be interval data. Okay, then think back. All the data you connect through Richter type scale, strongly agree, agree, neutral, disagree, strongly disagree, 1 to 5, etc. Do you think that's interval scale?
No.
No, right? I totally agree with you. Those data are not interval scale, they're ordinal. They're ordinal. So if they're ordinal data, why can you put them into the t-test, ANOVA, regression, etc.? When they assume your data should be interval. So that's wrong. The correct method to doing that is you do the Rasch analysis first. So you can transform all those ordinal data into interval. And then you perform the conventional statistical analysis with SPSS. Okay. So basically, you do the Rasch analysis first, then put the Rasch calibrate person measures into the SPSS. Then you can do the t-test, ANOVA, regression, whatever. That's the correct approach to do the analysis. Okay.
Thank you, Prof.
Thank you. Yes, we have further question for Kwan now. Hakim, yeah, please.
Thank you. Just for the objective assessments. That the
Sorry, I cannot. Sorry, I cannot hear you. It's very unclear. I cannot hear you.
Furkan, you need to come closer to the mic, please.
Yeah, I'm already close. Okay, what about now? Is it clearer?
Yeah, better.
Okay, thank you, Prof. About in educational practice, about the complexity of the applying the Rasch model analysis. most of the educators or teachers, they prefer like, for example, to rank the students. Can you explain more? How do we compare, or how distinctive the objectivity of just giving a traditional approach to the ranking of the students compared to the Rasch models? Because maybe this only, I just assume this can be an alternative approach, but at the end of the day, the result will be the same. Can you explain more about the objectivity comparing between the traditional approach and the Rasch model approach?
Okay. I'm not sure I 100% understand your question, but I will try. I mean, your question is mainly about in the classroom scenario, how we can compare the traditional analysis of the classroom assessment data with the Rasch analysis approach. Am I right? What's the difference between these two approaches?
Yeah.
Okay, so I think, as I said on these slides, if the teacher just interested in one test, interested in place students in order based on one test, then I think the CTT is sufficient. Okay, the raw data is sufficient, because raw data, even though they are ordinal, but they can help the teacher rank the student quite well. However, if you want to do some more advanced analysis, for example, if you want to check the student's development, which is very commonly interested in many school and teachers. For example, how can you tell your students after 1 year schooling have really improved in terms of their mathematics ability? Then you really need Rasch model. Because if you use the CTT, for example, you have a pre-test, you have a post-test, right? And in reality, we cannot use the same identical test paper, because the student will remember the items, and so you cannot control the practicing effects, right? Usually the pre and post test paper will be different, and if they are different, you cannot directly compare the student performance on these two different tests. Why is that? Because, as we previously discussed, if you use different items, then the student's performance will have a totally different interpretation. They will be interpreted in a different reference framework. So we need to make them into the same reference of measurement. Okay. A commonly used way is that we can build a common scale by linking items, which I will introduce a very interesting study in the second part. We can build a vertical scale. Okay, by building the vertical scale, then the students' performance on different tests could be easily compared under the same reference framework. So you can know exactly how much the student have improved or not. So I think back to the slides. If the teacher are only interested in this moment and one test, then use raw data, because it's very easy, straightforward. But if they want to do some more advanced analysis, checking the students, compare the students, they need Rasch measurement, because the Rasch measurement can put all the items and students into the same reference framework for the comparison, for the tracking. Okay.
Thank you.
There are some other questions. If we want to perform statistical analysis of the data yet from Rasch analysis, do we use data with logic? Yes. All the data calibrated by Rasch model, they are in a unit of logic units. Can we do it manually, like you re-input data in particular software? Why do you want to do it manually? If there's some software happy to do that, of course you can do it manually, because there are formula there. Yeah, but I don't see there are any necessity to do it manually. But yet, answer is yes, you can do it. You can do it, because you can just do it according to the formula. Okay. Okay. Is it okay to focus only on a certain number of items on the test, on a certain topic of focus to investigate student ability on test on the Rasch model? I think this is subject decision or conceptual decision. Take mathematics, for example. Usually, the primary and secondary school curriculum, the mathematics will have a different strands, right? For example, one area could be numbers, the second could be algebra, the third could be data analysis, something like that. So some teacher will say, I want to focus on the data analysis parts, not other parts. Then technically, this is no problem. You can just select the 5 or 6 items from those 30 items, which are focused on the data analysis part. You do your data analysis, Rasch analysis. Then you can have this Rasch item difficulty and the Rasch calibrated person measures. So simple answer is yes. But of course, with decrease of number of items, then the reliability, the precision of the Rasch analysis will be decreased too. Okay.
Thank you for your answer.
You're welcome. Okay, I think we need to move on to the second part. All these questions I think are very good ones. They are very practical, some are conceptual. So I hope answer can help you a little bit. The second part is applications of Rasch measurement in educational research. I will introduce briefly 4 types of application of Rasch measurement. And of course, this is not a comprehensive list of Rasch applications because Rasch application could be a very wide range of methods, approaches, or areas. Here, just follow them, which I personally have some experiences and have some real example. And I think are probably the most important or widely used applications among others. Okay, so I include them there. But you are most welcome to explore some new areas or approaches for Rasch measurement. The first of all is developing new instruments. I think this is the most salient application of Rasch measurement. As one of you have just mentioned, many people probably think this is the only area for the Rasch measurement application, but of course it's not. It's just one of the area, one very important area. The second, developing vertical scale and also Rasch plus path analysis, and the last one is application to classroom testing. Developing new instruments. Here is an example of my own study. I developed the self-assessment practice scale. One thing I want to remind you, anyone who wants to develop new instruments, the better to have a very thorough thinking or planning about your instrument development before you apply the Rasch analysis. Because you need to remember, Rasch analysis is just a measurement model, okay? It will help you, or it will set a golden standard of measurement, which you can use to verify your data. But it cannot answer the conceptual questions. For example, when I develop a self-assessment practice scale, I have to develop a very clear self-assessment process theory or model. Based on that model, you need to develop your items. So all the instrument development should be theory-driven rather than data-driven. Okay, you need to start with a conceptual map, a very clear conceptualization of the latent trait you want to measure. Here, I developed the self-assessment process model. There are several important actions in the self-assessment process. I will not go to more details. It's just a elaboration as an example. So based on those concrete actions, I developed some items according to different domains, okay? And then I connect the data, use the drafted questionnaire, and then put all the data into the Rasch checking. So the indicator could include Rasch reliability, response category functioning, item fit statistics, differential item functioning, or item hierarchy. Of course, there are many more different indicators, but these are, in my point of view, are very important and commonly used indicator of the psychometric properties of instruments. And another reminder for you when you want to do a validation study is that you need to have a validation framework to frame your data analysis. For example, in this study, I used Massic's concept of validity. So I checked all these, not all of them. I didn't have data to check the external and the consequential. So in this study, I checked 4 elements of the 6 elements. So in Massic's concept of validity. And according to the 4 elements, I organized my data analysis results into different elements. Okay, so the message here is you need to have a theory first. Based on theory, you develop your items. Then you connect your data. You do your Rasch analysis. And when you present your Rasch analysis, you need to have a very clear concept or framework of the validity. And then you organize your data analysis or your item development procedures under the different aspects of the validity framework. So that's the whole procedure to develop a new instruments. Here is a briefly summary of the methodology of the scale development. We have 22 items, 4 dimensions, and all items respond in a 6-point Richter type response scale. We have 1,400 Hong Kong students participating in this way. We identify 2 misfit items, and the category function very well. You can see all the step difficulty increased monotonically, and the Rasch reliability for the 4 subscales are quite good, etc. Here you can see the item measure that is in Rasch logics, standard error. So here's the item. This is item measure, Rasch measure, item difficulty. This is a standard error of item difficulty. In-fit MSQ, out-fit MSQ, these are the item fit statistics. Okay. Usually we will. There are different acceptable range of item fit statistics. Some people use 0.5 to 1.5. Some people use 0.6 to 1.4. Some even the 0.75 to 1.33. Okay, so I think the more stringent your acceptance level, that means your item, your instrument quality could be verified in a higher standard. Okay, and also we have done the differential item functioning across gender and across year level. Okay. Here is the item verbal maps. In this study, we used the multi-dimensional Rasch model. We used the Conquest, the software. So you can see, because the self-assessment practice, theoretically, we think it has 4 important actions. So we develop each action into 1 subscale. And this is the person distribution along these 4 subscales. And in the middle is the item distribution along the 4 subscales. On the right-hand side is the category responses. Okay, any questions regarding the instrument development and validation? So this is just very simple, a quick demonstration of the item development and validation study. Any questions?
Prof. Yanzi, I think you have to mention this one is using conquest, is it?
Yes.
Yeah. All of my students are more familiar with WinStep, but I think that's is only a matter of practicing using the software. Anyway, thanks. All right, guys, is there any question you want to ask? Okay, so we have a very wonderful lecture this morning, and then I think all of you are got some
Sorry,
different
Bamba, there are some questions.
Okay.
Yeah. Z asks, can I use WinStep for multidimensional scale validation? I'm afraid no, because WinSteps is designed for unidimensional Rasch analysis. If you want to do the multidimensional, I think you need to use a Conquest or a TAM. There is a our package, test analysis modules. Yeah, I think you need different software for different purposes.
Yeah, I think so. I think mostly for multidimensional analysis, you have to use R because WinStep are not designed for multidimensional Rasch model,
Yes.
right? Okay, so anybody? Miss Fanny, Novinta, Bueka, any question? Go ahead. Don't be ashamed.
It's okay. If no question at this moment, we can have the question at the end of the whole presentation. Okay. So I will move on to the second application. Vertical scale. I think this is a very appealing topic in education, but it's also a very challenging topic in education, because why is appealing is because the education purpose is one student to improve. And from the perspective of measurement, we need to understand whether students have improved or not. If we want to understand whether student improved or not, we need to have a very solid measurement to show that evidence. But current practice for different year level students, even within the same class, we will use totally different test paper. By doing that, we have no clue about whether students are really improved or not, because they are in different framework of measurement. We cannot directly compare the performance. So the vertical scale is for the purpose. That means we want to build a unified scale which provide a unified framework which we can compare the students' performance and different year level. Okay. So we have done this study with a very big sample. You can see the number of participants in different levels. Okay. The sample range from primary 2 to secondary 3. And we have developed different test paper for different year level. However, the crucial point is there are some linking items between adjacent levels. For example, there are linking items between primary 1 and primary 2. Linking item means identical item appearing in 2 papers. And also there are linking items between P4, P2 and P3, P3 and P4, etc., and so on. Okay. So by the linking items, all the test paper are so-called linked together. And then we run the Rasch analysis for the vertical scaling purpose. We have quite simple way to do that, mainly covering 2 steps. Step 1, we check the quality of the linking items with separate analysis for each level. This is because the whole vertical scale, the quality of the whole vertical scale largely depends on the quality of the linking item, because they are the anchors. They are the anchors between different levels. So we need to identify the qualified linking items so that to ensure the quality of the whole vertical scale. The step 2, after identifying the qualified linking item, we stack all data together and then do the Rasch analysis again. So by doing that, we can obtain all the item measures for the scale. That is vertical scale measures. For step 1, Okay, we also have some quite deliberated analysis procedure. First of all, we identify the underfitting person first. All the persons with MSQ higher than 2.0, we remove them because we have a very big sample, so we can afford to remove some person. And those underfitting person, they may introduce more noise rather than the useful information into the whole analysis. Okay, so first of all, we remove them, and then we do the Rasch analysis for the true adjacent level separately, and especially we looking at the linking item. Okay, if the linking item has a poor item fit, or the linking item have a too large difference for the two levels, they will be removed as a linking item. So the remaining linking item will be those who are quite fit to the Rasch model and who have a similar difficulty level for the adjacent year levels. Okay, they'll remain as the linking item. And then we stack all data together. The way we're doing that is for all the linking item, qualified linking item, okay, the data will be put into the same column in the Excel, while the unqualified linking item, we will treat them as separate items, even though practice they are identical, but we treat them as separate items. They will be placed into different columns, and all other items will be placed in their own column. So all the items from primary 2 to secondary 3, they will be placed into the same Excel file with some overlapping. That is the linking item. Then we do the Rasch analysis. Also, we have two steps. The first one, identify the underfitting persons, then remove them. The second part is do the analysis again. Then we got the item measures for all the items in the vertical scale. Here is the results. You can see that, honestly, the results not so good. The major limitation of the result is you will find the difficulty level does not increase too much from the primary 2 to secondary 3. And ideally, we would expect a more steep slope for this vertical scale. Okay, that will be better. I think we have sufficient big sample. We have sufficiently high quality items, but the only significant weakness in our data is we have very few linking items. Roughly, we have 15% to 30 to 20% of linking items. That means if a test paper contains 30 items, we probably have 4 or 5 linking items. And sometimes the linking items are not so good based on our criteria. Then we remove some of them. That means for some levels, they probably only have 2 or 3 linking items. So because there are so few linking items, so makes the anchor between the different levels are weak, not so strong. So which might result in the overall results not so satisfactory. So our lesson is, if you want to do a vertical scale, you should start with a little bit more percentage of the linking item. But if you have too many linking items, there are some practical issues. Because the student is too many link items, it's more easier for the student to remember those items, and the practice effect will be more salient. So there's always a double-edged sword in terms of determining the number of linking items. Of course, this is why vertical scaling is always a challenge topic for education. Okay, but anyway, I think our study demonstrated a quite straightforward but scientific way to do the vertical scaling. Is just depends on what kind of subject you select, how many linking items you will choose, which might largely determine the quality of the final version of the vertical scale. Okay, so I hope you can extend this line of research in your own subjects to build up some vertical scale. Probably you do not need to start with too aggressive targets, because we want to build a vertical scale from P2 to S secondary 3, which probably too much. Probably you can build a P1 to P3, right? It's already very useful for the student to check the students' growth from primary 1 to primary 3, which might be much easier in terms of the implementation. Okay. This is the by dimensions graph. Okay, any questions regarding the vertical scale? Okay, let's move on. The third application I would say is the Rasch measurement plus the conventional statistics. Before that, I would like to, actually, we have discussed this issue when you raise your question. The question is, what's the relationship between the Rasch analysis and conventional statistics analysis, right? I have explained in my answer. The appropriate way to use Rasch analysis and conventional statistics analysis is that you need to do the Rasch measurement first, transform the ordinal data into interval data, then put into the descriptive for inferential statistics, and finally you can make your conclusion. Okay, so Rasch model does not replace conventional statistics analysis, because you can see that Rasch model cannot do t-test. Rasch model cannot do regression. It's a measurement model. It's not statistics analysis. It's a measurement model. It's more fundamental. Okay, so Rasch model should precede the conventional analysis, but not replace the statistics analysis. Okay, and the construction of interval measures is a prerequisite of the statistical analysis. Okay, so you use, to put it simple, use Rasch measurement to provide interval scale, interval data. Then use the conventional statistics analysis based on interval scale to fulfill your own research questions. Okay. So based on this idea, we can say that Rasch analysis can be used in almost every research, quantitative research scenarios. So we need to do the Rasch analysis at the very beginning. The purpose are two-folded. Number one is use Rasch analysis to examine the psychometric properties of the scales. Okay. The second is to use Rasch analysis to generate Rasch calibrated Pearson measures. And then you can use these Pearson measures to do the Pearson analysis, regression, whatever. But there are some critical issues here. So I would say up to now, I don't think there are a perfect solution for this issue. The issue is how to deal with the standard error of Rasch calibrated Pearson measures. Because if you do the Rasch analysis to get the Pearson measures, then you put the Pearson measure into SPSS to do the further conventional analysis. Basically, you ignored the standard error of Rasch measures, because Rasch measure, remember, Rasch measure are estimates, not observed score. They are estimates. Any estimates, they are associated with standard error, right? So this standard error should be accounted in the subsequent statistics analysis. But currently, we do not have a very good way to do this. So there are several possible ways to deal with this issue, but I don't think they are perfect. For example, we can use Rasch software, for example, the Conquest or TAM, to generate a range of plausible values, okay, to represent the reasonably range of each student's measure on each latent construct. Then you can do the path analysis for each set of the Rasch calibrated person measures, and then do an average. This measure, I think this approach, to some extent, accounted for the standard error in an indirect way. You can refer to this reference for example. Okay. In our new edition of the book, Professor Bamban just showed you the applying Rasch model. We have proposed a new way to do that. That is because in conventional SCM model, there are two models, right? One is measurement model, the second is structural model. And for measurement models, we usually use the CFA, confirmative factor analysis, to fulfill the measurement model task. If in some software, because in this book, we just proposed a conceptual idea, but we do not have a software to do this. The conceptual idea is that we can use Rasch analysis to in place the CFA, which can do the measurement model task. And then, at the same time, we can use path analysis to do the structure model. By doing that, we perfectly solve the issue. That is, we use Rasch analysis to transform the raw data into interval scale data. But at the same time, because we are put Rasch model into the SCM framework, the Rasch measure standard error has been well accounted into the subsequent path analysis. Okay, so as far as I know, I think this is so far the most appropriate way to deal with this issue. But unfortunately, we do not have a software to enact this idea. So if any of you who are good at programming and for example, writing the R package, you can try this. I believe this will have a very big impact on the quantitative data analysis. Okay, so I strongly recommend you to think about in this way. Okay. Okay, this is a third example of the Rasch measurements application. Any questions?
Okay, any questions? So I think this is a very good challenge. If you can write the package in R or maybe specialized software, so you will be famous and rich and very influential. Think about that one.
I'm not sure whether you will be rich or not, but I'm sure you will be famous and influential. But probably you will be rich if you can develop your R package into a very commercial form and sell it to other people, right? That's possible. Okay, yeah. Let's move on. The fourth one is application to the classroom testing. I think I've spent quite a lot of my time on this topic in the past several years because, as you know, our university is a teacher education university. So we really spend a lot of time to promote Rasch analysis into the school setting. And we also found this is very promising. The teachers found this is very useful, especially for the individualized teaching and learning. The way is quite straightforward. Because most of the schools, they will have a data set about the students' performance on test paper in Excel format. Okay, so we can just use the Excel data file and put into WinStep. Now we use WinSteps. Okay, and this is very familiar with you, the item variable maps or right maps. the most important thing the teacher found is they can identify the students' ZPD. What is ZPD? It's zone of proximal development. Okay, I'm not sure about your background. If you are in education or psychological background, you should understand the zone of proximal development is very fundamental concept for education. If the teacher can identify students' JPD, it's very likely for them to find efficient follow-up to help the student to improve. For example, in this case, for the student, the left-hand side is the student's ID, the right-hand side is the item. So in this case, for the student ID 08, 20, 28, 10, 18, and 19, for this group of students, their JPD corresponding to the question 10, 12, 22, 17, 8, and 9. So what the teacher needs to do is probably develop a short worksheets covering those range of items, rather than the very difficult item Q24 or too easy item Q20 or Q23. Okay, so the student will spend their precious time on the areas or items they really need to invest time on. Okay, so this is a very important implication for the classroom teaching. And also the Rasch analysis can help the student, help the teachers to understand whether the test paper are well designed or not, how the quality of the test paper, the item fits, the correspondence between the item difficulty and the student ability, etc. Another very important or interesting implication is in WinSteps, they will provide one figure for each student. And in this figure, the teacher will identify, according to the student's ability, which items are they need to follow up after the testing, especially on the left up area and right button area, highlighted by yellow area. For example, for 21 item, which is higher, ability is high, difficulty is higher than student's ability. However, the student got it correct. So the student needs to understand whether you are guessing, you are cheating, you are really understanding or not. For this area, all these items difficulty should be lower than the student's ability, but the student get them wrong. Okay, so for teachers and students themselves, this very message, why you get incorrect answer on those easy items, because it might indicate that there are some very basic understanding, basic concepts the student have not mastered. Okay. So because of the time, I cannot go into more details, but I think this figure, as well as the item map, should be the two most important figures for classroom teaching teachers. Okay. If you are interested, I can share with you these examples, which I used Rasch measurement for different purposes. For example, I used the first group of paper, I used Rasch measurement for examining the instrument psychometric properties. And I also have several papers I used Rasch plus past analysis or Rasch plus regression or with other conventional analysis. But for all this second, third, and fourth group of papers, you need to be aware that we are using some imperfect way to do the Rasch plus past analysis, because some of the paper we have not accounted for the issue of standard error of Rasch measurements, Rasch measures. Okay, so we are looking forward to someone, probably some of you, to generate some our package which can deal with this problem. Of course, I would recommend you to read this book. If you are really interested in Rasch measurement, I guess this is the bestseller, I would say, in the Rasch measurement domain. We have provided very a detailed description about the major features of Rasch measurement. Also, we have provide the example data for each chapter for you to follow to try practice your Rasch measurement, Rasch analysis skill. And we have a prompt. I believe Professor Bamban have introduced you this society. Is very dedicated society for the Rasch measurement. We have an annual conference held in the Asia or mainland China every year. So the next year we will have a conference in Malaysia in the middle of August. So if you are interested, you are most welcome to join. And I believe Professor Bambam will organize a group of you to attend, right? So I'm looking forward to meeting you there. And also, one of the organizers next conference, Professor Zali, is in the room. So Professor probably Zali can provide more information later about the details. And also, there are some websites and papers you can refer to for Rasch measurements software. I think you are most familiar with the WinSteps, right? But if you are from the language testing area, probably you want to try facets, because facets can help you to deal with the rata effect, which is a very important issue in the language testing domain. If you want to do the multidimensional, probably you can try Conquest or even better, TAM, because this is our package, it's free. And both the Conquest and TAM are developed by the same group, same leading author, Professor Margaret Wu. Okay. Okay, I think this is the end of my sharing. Welcome any questions, comments, and feedback. Thank you.
Okay, thank you very much, Prof. Yanzi. So it's very insightful and then very wonderful to have your thought and then showings about the application of Rasch model, right? So could you maybe just off the screen in terms of share screen?
Pardon, Bamban?
Close the share screen.
Okay. Yeah.
All right. Okay. Thank you. So, as already mentioned by Prof. Yanzi, next year in 2024, we have PROMS conference in Kuala Lumpur. Dr. Zali is one of the committee. You want to say something, Dr. Zali?
Yeah, tentatively, the conference will be held 19 to 21st August in Kuala Lumpur city itself.
Okay.
So you have a lot of accommodation and also things to do other than the conference itself.
Sure.
We'll announce it in the PROMS website and also in the Facebook soon, I guess. It will take us about 2 or 3 weeks to finalize the flyers.
Okay. Thank you, Dr. Zali. So I think those of you who have papers or have some plans using Rasch model in your research, so very welcome. Kuala Lumpur is not very far away from Jakarta or Depok, so you can catch easily only around 2 hours flight, right? So we will meet you there. All right, so we go to the discussion section. So if you have any particular question that really burn you, want to know, I think what Professor Yanzi already explained is complete from philosophical aspect and then go to the technical and then the application itself. Okay, anyone? Okay, go ahead. Or you can just write your question in the chat room if you cannot speak directly. Okay, anybody? Miss Fanny, Miss Nurul?
Yeah, can I ask questions, Professor?
Yes.
So I'm going to confirm my understandings about the classroom testing as the one of the RAS applications that you mentioned. You mentioned that the RAS analysis can also helps us to find the zone proximal development of the students. So can we also use it as the way we are differentiating our instructions or making the personalized instructions, because the groups of the students has a different ZPD, or how you are actually using that kinds of informations in the implementations of the classroom teaching and learning currently?
Yeah, I think that's very good question in terms of a classroom application. Yes, I think a very straightforward way we can use the JBD, the item variable maps is you can group the student into different groups. I think, okay, in an ideal situation, we should provide individualized instruction to individual students, right? But in practice, the classroom teacher cannot afford to provide individualized feedback to individualized students. So a compromised way is that we can combine the student into different groups. For example, 4 or 5 groups within the same class. So the top one, they will have their separate worksheets which focus on the ZBD. The second group, third group, etc. They will have a different worksheet, will follow-up worksheets focus on the EPD, ZBD areas and items. And also sometimes some schools, the teacher will develop differentiated homework for the students, also following the information provided by the item parameter graphs. However, my point of view is that a real ideal situation for this application is that we need to teach the student how to read and interpret their information. For example, if every student can understand the diagnostic PK maps, the second map I showed, it's very powerful in the tool or information for student individually to understand their strengths and weakness. Because, for example, some items very easily, but they got wrong. But the student can very easily try, oh, this is just because my carelessness. Okay, I don't need to care about it. Next time we will be more careful. That will no problem. Or for some very difficult item, the student get it right, get it correct, but it's because the student gave a guessing because this is MC items, right? Then the student will understand, even though this time I'm lucky, I get it right, but I still need to spend time to work on this type of item because I do not really understand it. So if we can teach the student to understand this kind of information, that will be very, very powerful self-regulated learning tools. Because for teachers, still, there are some practical constraints. Even though you have such information, they do not have time to follow up, right? So I think the future direction is that we need to enhance the students' assessment literacy so they can make full use of the information.
Thank you, Professor. Maybe for the second question, I wondered about the linking items. Because you mentioned that this is actually the things that we need to give the emphasis when we are talking about the vertical scales development. If we are talking or creating about the linking items, so we should start with the lower grade, with the ones that they need to understand, and for the higher grade, is it actually the items that becomes the prerequisites?
Yes, very important question again. Okay, I don't think there is a golden standard or golden answer for this question in terms of selecting linking item. But I think your direction should be correct. That is, the difficulty of the linking item should not be too high. It should not be too low either. Because if it is too high, that means for the lower level students, they will have a zero probability to get it correct, right? But it's too low then for the minutes for the higher level of students. So we will suggest, based on our own experiences, we will suggest to choose some items which are not so curriculum based. Not so curriculum based means the student, even though they have not learned it, but they still have some probability to get it correct. Even though students have learned this topic, it's not necessary they will get it easily correct, right? So more or less, you should select some item more close to the generic skill on that domain, so that it the difficulty of that item for the adjacent level will not be too big, because our second criteria for qualified linking items is that the difficulty level of the item for the two adjacent levels should not be too big, right? They should be quite reasonably close. So our experience is that you need to select some item more close to the generic skill of that domain.
All right, thank you, Professor.
You're welcome.
Okay, Prof. Yanzi, there's a question in the chat room from Miss Eka.
Okay, for the first question, I would say from the perspective of a Rasch person, definitely yes. You should do the Rasch analysis to transfer all the data into the interval scale. Then you do the whatever you want, t-test or comparison. So I think that's the basic standing point. Of course, but I always say that even it really depends on where you're standing. For Rasch person, all the analysis should start from Rasch analysis. But you understand in reality, many journal papers, they do not care about whether you do the Rasch analysis or not. If you just do the raw data, you do the statistics analysis based on raw data, it's okay. So instrumentally, I think you need to consider the target journal you aim at for your work. So there's some journal paper more measurement oriented. I think you need to do Rasch analysis, but for some more general scale, journal, probably up to you. Okay, but you need to understand, even though you do your analysis on raw data, you need to understand which is inappropriate. Okay, as a measurement person, you need to understand that. But in reality, we always do something wrong, even though you know that, right? So this is a difference. You know it or you do it. Okay.
Somebody raise hand. Miss Nurul, you want to ask question directly to
Yes,
Prof. Yanzi?
thank you, Pak Bambang.
Yes.
Thank you, Professor Yanzi, for the very insightful material. Here, I would like to ask about misconceptions because, as I understand, RAS modeling and measurement has significant potential for detecting misconceptions. And then I would like to ask, what methodologies and considerations should I concern in developing scoring rubrics aligned with RAS modeling principles to accurately capture the student understanding, particularly when targeting common misconceptions among students? And how can these rubrics can be designed effectively to differentiate between the level of understanding and misconceptions while ensuring the fairness and reliability in assessment? Thank you, Prof. That's all my questions.
Okay, thank you. I think that's a very common question many teacher educator will have. My thinking is Rasch measurement cannot help you to address that problem, but it can help you to verify what you have done is good or not. The meaning is whether you can develop appropriate rubrics to differentiate the student different level of performance against to the learning targets or learning progressions is a more conceptual issue or subject issue. For example, if you are a mathematics teacher, you need to develop a very appropriate rubrics which can differentiate the student's performance on the addition or subtraction or the understanding of this concept, right? So this is a more subjective, a subject-based knowledge or expertise. Once you set up that rubrics already and you connect your data, then Rasch measurement can help you to verify whether this level are sufficiently distinctive. For example, you can check the category function indicator. If the category indicator are increased monotonically and the distance between the indicators of along this rating scale are sufficiently apart, that means your rubrics are well designed to differentiate the student's performance on these latent traits. Otherwise, if the distance between the indicators are very close, or even sometimes they are disordered, that means your rubrics are not so good. So I guess it's just like you're developing an instrument. Rasch model cannot help you to develop instruments, right? You need to have your conceptual understanding, your theory building ability to build this item first. Then use the instrument to connect data. Then Rasch model help you to verify whether your instrument or item, your rubrics are good or not. Yeah.
Thank you, Professor.
Welcome.
All right, so I think the last one should be from Mr. Samsir in the chat room.
Okay.
What I'm currently studying is Rasch analysis using multiple choice question. How can we optimize students' learning outcome, for example, by using open-ended question or possibly conducting diagnostic on specific skill? Or how can we identify learning style using inventory instrument through Rasch analysis? Okay, I think some of it I already answer actually with your explanation, but okay, go ahead, Prof. Yanzi.
Yeah, I think this question, in my understanding, is quite more or less similar to what Lovita just mentioned. You need to rely on the subject or conceptual expertise to answer these questions, because Rasch measurement is a measurement model. It can help her to testing your data, testing your model, testing your conceptual idea from the measurement perspective, but itself cannot help you how to identify the learning style, how to optimize student learning outcome. So I think this is more theory or conceptual, subject-based conceptual questions. Yeah.
All right. Okay, thank you very much for the answer, Prof. Yanzi. So we have you in the 2 hours and 15 minutes. So it's very wonderful time that you already shared to us about many aspects of the Rasch model. So from deep of my heart, thank you very much, Prof. Yanzi. I think we learned so much from you and your explanation, and very happy to have you here. And hopefully next year you also will be available to share with another group of students. So this is PhD class. This is the second batch from our PhD program. Okay, so one of the what you call is concentration is about educational assessment. So I teach educational assessment and evaluation for this concentration, and then some of them are very interested in terms of continuing their research using Rasch model. I think like Afan, Hasnan, in the context of language assessment. So most likely they use facet, and then but of course understanding philosophical thing and practical thing using Rasch is very important. So with that, thank you very much, Prof. Yanji, for your valuable time and kind sharing to us, and very happy to have you here. And with that, I just close this guest lectures. So thank you and good luck and goodbye. Okay, bye.
You're welcome.
Thank you, Prof.
I
Yanzi.
also very enjoy this talk, and obviously Professor Bambang have done very good job on supervising your students. So I feel lucky for you. So hope to see you in some occasions in the future.
Yep, sure. Hopefully you can visit you in Hong Kong maybe next time.
Yeah, sure. I hope so. Yeah. See you.
Okay. Okay, bye everyone. Okay, I will close the room. Okay, bye. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Pak
Thank
Bambang.
you, Professor. Thank you, Dr.
Thank you,
Bambang.
Professor.
Thank you so much.